multiplying integers. So the first thing I want to talk about, because I'm sure that you guys all know what multiplying means, or at least you know how to do it. But what about this word integers? Is integers a new word for anyone? Yeah. So in math, right? Math is in a way the science of numbers, right? And numbers, we have all the numbers in the world, right? We wrote them all in one circle. They can look like a lot of different things. So mathematicians divide up the numbers and give them different types of names, right? So most of the numbers that we're ever going to deal with, so this is like a circle that's maybe just a little smaller than all the numbers. These are called the real numbers. There are things that are outside of the real number circle. Okay? Something like this.
Integers.
The square root of -1. That's a number, but it's not actually a real number. Okay? But real numbers is probably most things that you've ever heard of. And we divide real numbers up into two groups. We have rational numbers, and we have irrational numbers. Irrational numbers are something like the number pi, right? Or the square root of 2. These are numbers whose decimals go on forever and never repeat. Okay, so they go on forever and ever. They don't end and they don't repeat. So in a way, they're numbers that we can't really write as decimals, because if we did, it would just have to be like 1.2351725, and we'd have to keep going forever and ever. We might use like an ellipsis, right? A dot, dot, dot.
Write down pi.
Yeah, so pi we often write as 3.14, but technically it's 3.14 and then a whole bunch of other numbers. It goes on forever, right? So they go on infinitely. Rational numbers are numbers that end. They either repeat or they stop altogether. Yeah.
How come on Pi Day only the teachers get pie and not the students?
Yeah.
What are you talking about?
At our school, the teachers get pie and eat them right in front of us, but we didn't get any pie.
Pi Day.
Well,
Pi Day wasn't one to say.
so within the rational numbers, we have actually different types of numbers. And so rational numbers would include things like 1/3, because that is 3.3. It goes on forever, but it repeats. Right? It would include something like 1/4, because that's a number that just ends. It's 0.25, and that's it. There's no more numbers after the 5. Right? And within the rational numbers, we also have a group that we call the integers. Integers are just numbers that don't have decimal points. So the integers would be things like -7, -22, 0, 5, 273. So integers are just numbers without any decimal at all, right? Now within the integers, technically these numbers over here are also called the whole numbers. I'm going to abbreviate numbers like this. And then within the whole numbers, all of the whole numbers except 0, I'm going to use an arrow. These are called the natural numbers, also known as the counting numbers. Because if you think about, if you wanted to list out all of the counting numbers, the natural numbers, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to the highest number you could ever count to. The whole numbers are the same thing, but they just also include 0. And then integers are all those numbers plus the negative numbers. So integers, in a way, is another way of saying, like, integers are basically all the positive and negative whole numbers. That's kind of a way of saying it in English. Because we kind of know that term, whole numbers. A lot of people use that. Whole numbers are numbers that don't have decimal places. Right? But the integers is a less commonly used term. And it just means all the positive and negative whole numbers, which, remember, that also includes 0. 0 is not positive or negative, but it is a whole number. So we're going to talk right now about just multiplying integers together. And you've done this probably since 3rd grade. You've multiplied integers. When you first started learning your times tables, 4 times 5 is 20. 7 times 6 is what?
42.
42. 7 times 8 is 56. 8 times 9 is 72. But what if we add in a negative? Or what if we add in 3 numbers? 6 times 5 times 2. Right? Most people haven't really memorized all of the possible ways that you could multiply integers. So we're going to look at some tricks for how you might keep track of those longer multiplications and how you can tell if the product is going to be positive or negative. So let's start there. How do we know when we multiply 2 numbers if the product is positive or negative? Well, there's a pretty simple rule. A positive times a positive always equals a positive. So 2 times 2 is positive 4. It's never going to just turn negative. Right? Also, a negative times a negative equals a positive.
Oh, I know.
It's kind of like saying the opposite of the opposite, right, is what you started with.
Or,
The negative of a negative is a positive.
or you can just like flip one of those negatives around and put it on.
Yeah, sometimes you'll see people, so I should probably put a little dot, right? A positive times a positive. A negative times a negative. Sometimes you'll see people kind of like join them together to make one big plus sign. But what is a positive times a negative?
A positive? No,
That's
it was a negative.
It's going to be a negative, and so is a negative times a positive. So there's kind of a pattern to this, right? If you multiply 2 of the same number, the same type of number, you get a positive. If you multiply 2 different ones, you get a negative. So for example, 8 times 8 equals
64.
positive 64. What about negative 7 times 5? Negative 35. Because one of those numbers is negative. How about 12 times negative 3? 12 times negative 3.
12 times.
So the important thing to remember, we're multiplying. So we figure out the negative first. Since we have one negative, our answer will be
No.
Let's think about it. Are we multiplying a positive times a positive here?
No.
Are we doing a negative times another number?
No, it's gonna be 12.
It's gonna be a negative.
It's going to be a negative answer. And now let's just say, what is 12 times 3?
12 times 3.
Does anyone know?
36.
36. So our answer is negative 36. Right? I'm multiplying the numbers. So I just multiplied 12 times 3 to get 36. The negative sign is just coming from there. So what if I had something that looked a little bit different, like negative 5 times negative 8? I'm still multiplying these two numbers. So I'm still going to use the same rules. I just wrote it a little bit differently, right? Negative 5 times negative 8 is what?
Negative 40.
Is it positive or negative?
Positive 40.
Why is it positive?
Because a negative and a negative equal.
A negative and a negative equal positive.
No,
So
I'm getting this.
positive 40. It doesn't matter how you write it, right? I could write it like this. 4 times negative 2. What's that?
It would be
A negative.
negative
A negative, and 4 times 2 is
8.
8. So it's a negative 8. Now, we often don't see the x used for times because x tends to mean something else in algebra. But we're just going to practice writing multiplication in a whole bunch of different ways. It doesn't matter how you write it. It always is going to equal the same thing. Okay, I'm going to leave those rules up there. Now I want to talk about longer strings of numbers. What if I had something like this? 6 times 5 times negative 2. So when I have a longer string of numbers, what you have to realize is this is not one problem. This is two problems. What's the first problem?
6 times 5.
6 times 5. That is one problem. 6 times 5 is one problem. So what is 6 times 5?
30.
It's 30, right? So I would say 30, and now I'm going to take 30 times negative 2. So that's a second problem. Yeah. And 30 times negative 2 is what?
Negative 60.
Negative 60. So do you see how I did one problem and then I did the second problem?
Yeah.
It's really important to try to keep track of both problems, right? What if I had something like this? 5 times 3 times 4.
So 5 times.
Now technically it doesn't matter which order you do multiplication in. I could do these two first or these two first. And since I don't know my 15 times tables, but I do know my 12 times tables, I would probably do 3 times 4 first. 3 times 4 is what? 3 times 4? 12. And then I would do 5 times 12, which is 60. Right? 15 times 4 is also 60, but 15 times 4 is a less familiar fact because you don't often learn up through your 15 times.
I have a.
Yeah.
So, we did it the opposite way,
Uh-huh.
and I got a different answer.
You didn't get the same answer. 4 times 1 is?
Oh,
4
never
plus
mind.
2
We're good.
is? Yeah. That's good. Yeah, if you do it the opposite way, you will get the same answer.
Okay.
Yeah. And so it's also a way of checking your work sometimes, right? Oh, if I did it the other way, do I get the same answer? But what if I throw in a couple of different negatives? What's going to happen if I've got something like 5 times negative 2 times negative 7. It's a lot of negatives all of a sudden. But just remember, we've got two separate problems. So 5 times negative 2 is what?
So negative 10.
Negative 10. And negative 10 times negative 7
It's positive 70.
positive 7. So do you see how we had two negatives in total?
Yeah.
Two negatives in total equaling a positive? You can kind of predict ahead of time. If you've got two negatives, your answer is going to be positive. If you've got one negative, your answer will be... If I just had one negative like this, what if I had this? 3 times negative 5 times 2.
3 times negative 5 times 2.
So what's 3 times negative 5?
Negative 15.
Negative 15. And negative 15 times 2 is?
Negative 30.
Negative 30. So when I have one negative, my answer will be?
Negative 30.
What if I have 3 negatives?
Well, then
Negative
they'll
4
equal a positive. Wait, no, they won't. They will equal a negative.
4 times negative 10.
Well, the negative 4 plus negative 4 will be positive 16, but
Okay.
so
this will be positive 16.
but positive 16 times negative 10 will be negative 160.
Yes.
Whoa.
So the answer when I have 3 negatives is negative. Because, just like Marika pointed out, these two cancel each other out.
Yeah.
And so I'm just left with this one over here.
Oh, okay.
Right? Very good.